Hi everyone. I start to produce a series of the video, my lesson. So there are two types of video I'm going to post. One of them is today I'm doing like lesson video about the theory and about the concept we been present in this class here. And the second type video is about tutorial. I'm going to go straight to the question. For example, if you ask me, you send me to Hapara saying, okay, I don't understand the number 5, 5.2, and number 8, 5.2, for example. Then I know which one you confused, still confused. And I will produce the video if many of you have the same question. Otherwise, we will meet in class and I go one-on-one with you. Okay. So now let's start with the most confusing property of the linear velocity and angular velocity. So let me go this way. You remember, you know that the distance equal the speed times time, right? Right? You ride a motorbike 30 kilometers an hour and you go 5 hours, so you cover 150 kilometers. Okay, for example here, the distance is you ride like 30 kilometers an hour. Okay, and multiply by 5 hours. So therefore, this equals 150 kilometers. So the hour here cancel that hour. See that? So it turned out to be a distance. So the same thing in linear. When you have the point here we call the initial point on the circle, and the point moving along the curve of the circle, okay, the arc of the circle somewhere here. So now the total, the length of the arc can be represented just like distance. So we call this, usually call this S, right? So the same thing here, we have the formula here, the distance equal velocity times time. The same thing. Okay, speed here with velocity, the reason is because if you go this way and the velocity becomes negative, it's different from the speed. Okay, the speed always positive. So therefore, this one here, and if you solve for V, so V has to be the total distance divided by time t, right? So the V here, velocity here we call linear velocity, because it's going to a straight line. So if you bend it in a straight line, right? Just like you rode straight on the road, so this one like the earth, right? You go straight, you know, just like you ride a bicycle on the surface of the earth. So the velocity equal the total distance divided by total time. So let's talk this one. Okay, this is the first formula we learned about, we call linear. Okay, now I'm talking about angular velocity. So how it's different from the linear velocity. So here, take a look. You have this at the angle, right? For example, your angle, you start from here. So now let me give you the angle velocity. Let's say the angle, angular velocity of this angle here is 10 degrees per second. So then 1 second you go 10 degrees, 2 seconds 20 degrees, 3 seconds 30 degrees, and 60 seconds is 60 degrees. So now here is how it looks here. So okay, so now you have 1 second you go 10 degrees, 2 seconds 20, 3 seconds 30, 4 seconds 40, 5 seconds you have 50, and 6 seconds you have 60 degrees. So the 60 degrees total angle is made in 5 seconds. So you have 60 degrees, you have W, you have the total angle equal W times T. W here the rate of change of the angle, 10 degrees every second, 10 degrees every second, and after 5 seconds you have total 60 degrees. So this one here is compared with this. So let me put in here S equal V times T. Total distance equal the velocity times total time. Now the total angle equal angular velocity times time. Okay. So that is, they have different characteristics, but they have the same way to think about. Okay. Finally, we have we divide by W. So W equal total angle divided by time. So we have two times of velocity. One is linear velocity here, and the other is angular velocity. How fast the angle changing, depends on how fast the point moving, just like the speed you go on the straight line. Okay. So the next one, we're going to try to connect them together. To connect. So I want to find out if I know the angular velocity and I know the radius of the circle, can I find the linear velocity? So now I try to connect them together. So we have the middleman right here. The one, remember, in the past we learned like this. If we have the angle here in radian, angle theta in radian. So the formula for the arc length from here to here, we call the arc length, right? The arc length, the line of the arc. So the formula say, so the arc length equals the theta times r. The theta has to be in radian. So we remember we derived that formula, right? So we pretend we know this, and we know this. You able to know this. So the formula based on the ratio, you know, the length s over the n times circumference 2 pi r, circumference 2 pi r has to be equal the angle theta over 2 pi. The ratio of this angle over the whole thing equals this line here over the whole circumference. So then cancel 2 pi here. You multiply by r, you also have s equal theta times r. So this is the formula for the arc length. If you know angle and then you know the radius. So I just want to try to connect this to that. So we substitute this for s here, right here, for s here. So now my velocity becomes velocity equal theta times r divided by t. Okay, substitute for s here. Now look, what that means? Theta over t equal w. Equal w. So I just substitute w here. So finally, I have v equal w times r. Okay, that is the relationship between angular velocity to linear velocity. Yes, that. Okay, now I did application. I don't show you how to solve the problem, but I show you relationship between angular velocity and linear velocity. So we have a couple of the problem with the bicycle, right? Now you see, you look observe here. When you pedal this on the sprocket, and this on the wheel sprocket, so this on the smallest, this on the big, and the wheel itself, the diameter, the biggest, right, the longest one. So you think about, okay, the point here. When you pedal, if the point moves wrong, right? That means the point on here and the point on here have to be the same speed. Okay, have the same speed. So now have the same speed, same velocity, but if you pedal it, you go like this. So this one has to go a lot more than that. Okay, you see the same speed. Therefore, this angular velocity here is slower than that one. Okay, you see that? When this one go like 5 inch per minute per second, right? This one 5 inch per second. So this one go beyond this one. So therefore, the angular velocity here is slower than that one. However, if you talk about this sprocket here and the wheel here, the angular velocity stay the same. Okay, stay the same. Because if this one go all the way from here, this one go all the way from here. However, the linear velocity of this one and this one completely different. So you imagine when you pedal it, so the point here move from here, move all the way from here to here, make it the distance like this. But at the same time, this one move all the way from here to here. So this distance much more longer. So therefore, if I want to find the velocity of the outsider, so you multiply by r. The velocity is a lot slower, linear velocity is slower than that. The angular stay the same, you see angular same, both of them turn the same angle. but the velocity here go from here to here. This one cover a lot more run, right? So the velocity here, so linear velocity here a lot faster than this one. But angular velocity stay the same. On the other side, this is small, but the linear velocity the same with this one because the chain move them the same speed, okay? Therefore, the angular velocity here is smaller than angular velocity here. So that's all relationship between linear velocity and angular velocity. But